Um, this is a lab that I got from Facebook. The talking about pretty much what they did was they made it available and they asked for help about it. So yeah, I belong to that group. There's also a CCNA, a Cisco CCNA study group um, on Google Plus as a community. We most of us who are actually in the CCNA study group on Google Plus are also members of CCNA study Cisco CCNA study group on Facebook. So let's just say that this is a sister group where we answer mostly questions and achievements. We try to encourage each other here. We do more hangouts in the Google Plus community. This lab in itself wasn't really wasn't really structured well. It's going to take a bit of an invention on my part to get everything to work. And well, they did try to, but most of the stuff were like, example, the labeling was a little too close. So it's gonna be a little bit of a challenge, but it's not too much. We should be able to get this done. I should be able to get this done. I'm the only one here for now, anyway. All right, cool. So let's start. Now, before you start any lab or any stuff like that, it's always best to have a game plan. So my game plan is this. I feel that the routers will be easiest to configure first. So I'm going to go ahead and configure the routers first. Router 0 and router 1. Configure that first. Then I'll go to the switch on top. Then I'll go to the switch below and I'll work on Ether channel. Do notice is this. The lab is meant to run OSPF, correct? Well, we do have a difficulty here because unless I make the gigabit 00 trunk ports and actually put an IP address on VLAN 1 that is shared across both router 0 and router 1, OSPF can't communicate. It's essential to remember that multicast packets and broadcast packets are not sent beyond a subnet or a VLAN. So if it comes in, if a broadcast frame comes in on a switch on VLAN, let's say 2, though it's broadcast, the switch is not going to send it out on all other ports that are on different VLANs. Zoom is only going to send it out on all ports marked with the same VLAN, and Zoom will tag the broadcast frame as it goes out. But that's if you have it as you've not configured it as an access port. So if that's the case, if you look at it from the description, we have two VLANs, 20 and 40, 10 and 30, right? Yeah, I selected it here, 20 and 10 and 30, 20 and 40. Now, unfortunately, they are we do not have any commonality, or no, there's no common VLAN across any of those devices. So I'm just going to use VLAN 1 as the VLAN across the device, and I type VLAN 1 network address will be 20.20.20.0/24. So that's the VLAN 1 IP address I'll be using. And I think I should draw a box or something like that here. Draw a rectangle. All right. Okay. And a field color for it. So this is an addition I am making. Come on, field color should be what? Let's keep with. Okay. So what? Oh, like I said, I'm new to this. I'm a genistry guy. I'm largely a genistry guy. I'm not. Okay, I'm not to delete that. Yes, and I'm gonna have to move this and then select both and move both here. So the theme is VLAN 1 is going to be using 2020.20.20.0. All right. So I'm going to assign IP addresses on the fly. I'm going to add some stuff there. So I'm just letting you know what the game plan is. We're going to have it a channel also on the switches, 3 switches below. And we'll be having a trunk, but largely I'll be configuring trunks on the router. So let's get going. Let me move this here so it's easy to see. All right, cool. Let's get going. So router 0. Nope, I do not want setup. Enable. I'm gonna configure the host name just to make it easy for me to know what I'm working with. Router 0. Okay. Now I'm gonna go next to the interface. G01. That's the upstream one, right? No shot. Now, what's important about this is that we're told from the description that the VLAN is VLAN what? 40? It says 20 and 40. Now, I do know that VLAN 40 is on the upstream here, PC3. So definitely, I know that this trunk over here, G01, I'm going to have to configure a sub-interface for VLAN 40. So I immediately go there, interface G01.40. Note .40 doesn't make it it doesn't enable VLAN. It's just a marker to make it easy for me to remember. So encapsulation actually is what makes it enables or starts up the VLAN part on the interface. So now take note, I do have a chance to make it native, to make .40 native, but I intend to make VLAN 1 native across board, right? That's my intention. And I'm going to make it a trunk port anyway. So VLAN 1 is native by default. So I'm just going to make this 40 the way it is and go on. Before I go, do I need to put an IP address, right? So what's the IP address on 40? Now take note, it didn't really specify what we should put as IP address for the lab didn't add IP addresses there. So I'm going to go on the fly. All router interfaces should have .1 on VLANs that they own. On the VLANs they share, I'm going to specify different IP addresses for them. Okay, and I'll have to do that on the fly. Hope I remember. All right, cool. Let's go. So what's it is 10. But this is a good subnet. Easy to not mess up because it's a /24. All right, so I do hope you guys can see this. I'm trying to record it. This is my first time trying to record using what to call it, Google on Air. All right, so I also gonna configure interface G00, no shot. It's important to make it to use a no shot. Now remember, I said I'm going to use VLAN 1, right? Now it's important, as I said, to have a VLAN that's common to both routers so that OSPF can work. And that's why I'm using the VLAN subnet of VLAN 1 20 20 20.0/24. This that's why I'm using this. All right. Let's see if I can get this. So on gigabit interface 00, I'm going to configure an IP address because the VLAN for that is 1. Anyway, so IP address, I'm going to go for 20.20.20.1 to 255.255.0. And now I'm going to configure the sub interface. Sub interface should be for VLAN 20 because we'll specify that we only have VLAN 20 and 40. 40 is upstream. As we can see, 20 on the other hand, if I can show you, VLAN 20 is on this side. This is VLAN 20. I moved it too far. All right. So 20s, that's 20. View, zoom, toolbars, options, preferences. I think this should be it. Fonts. CLI fonts. Let's make it bigger. 20 is good. Apply. So that should make the fonts bigger. Okay, here we go. All right, so definitely we can see that now. Maybe I made it too big, but I feel it's important that we actually see what I'm doing here. So interface G00.20, that's the sub interface. Note sub interfaces are on by default. Um, Next, I'm going to configure the IP address. No, no, encapsulation. You must configure the encapsulation before you configure the IP address, otherwise you get an error. All right, so 20, right? Remember, I'm not making it native. Um, IP address for 20 is what? What's the IP address for 20? Okay, so he's using a network mask of 172.16.0.0/16. All right, so I'm just going to make it 172.16.0.1. Remember, it's a /16, so that's what I'm going to have to do here. And then, in addition to that, I also remember that we do have OSPF running, right? Cool. So I'm going to just write OSPF router OSPF. What process number it really suggests? No, this process number is only important locally on the router. So let's do this. Okay, I'm going to specify a router ID. He didn't specify that, and he didn't indicate that we should put up a loopback interface either. So I'll just specify router ID 1.1.1.1, and that should do it. And then I'm going to cheat on the network. Really, I should. It's rule of thumb to configure your network commands to reflect each network. Well, I'm going to cheat on this. Uh, just want to make it quick. Nope, I don't need that. 255. Right. So pretty much what I'm saying is this: I don't care about what IP addresses we're talking about here. Now, in particular, I'm using this because I know I'm not using any loopbacks. All my links are transit links. Um, Transit means I'm connected to maybe, well, actually connected to, no, they're not all transit links actually. Transit links really are you're connected to another router. Um, I think there are others that stop there, but I'm not using loopback interfaces, so I'm just specifying that all my interfaces should advertise OSPF, which is what I want to do. Um, so let's go ahead and see what we do here. Now, in reality, though, I shouldn't really be advertising OSPF on G01 on for VLAN 40 because I do not want my PCs to be seeing OSPF traffic there. So but let's just say this: I can always go and turn on passive interface to turn off the interfaces I do not want OSPF advertised on. I remember to always put area 0 or the area, and but as I said, this is just a quick cheat. I'm trying to quickly run this through. Let's see. So what do I have now? Do show protocol. Uh, Show protocol. Okay. You see, I have my VLAN on G00 VLAN 1. That's 20.20.20.1. I have a sub interface 172.16.0.1.6 and 1/16. Um, my G01 is also up, but I do not have any IP addresses configured on the VLAN 1 part of G01. Gigabit interface 01.40 is up. Line protocol is up. And my internet address is 10.254.254.1. All right, so it says G02 is administratively down. Line protocol is down. Serial interface, da. Yeah, so the other interfaces are down. Now let's see what we have in show. Do show IP protocol. Um, now this just tells me about my OSPF configuration. So I do have OSPF running, process 172. I do not have filters enabled here. I have a router ID of 1, maximum pass of 4, It says I have a maximum area of 1, and said normal area, right? It's not stub. Okay. I do this a cheat I use there to just say advertise all interfaces. I don't care what it is, just advertise all interfaces and sub interfaces included. Set gateway is specify itself as a gateway. Of course, we do know that the AD for OSPF is 1100. Okay, so I think I'm set with this one. So do copy, run, start. Right, I saved that. Now let's go to G02 and G01. Oh, I'm saying route 1. My bad. So config T. Remember hostname. Router 1. Okay, cool. Now I do the same thing. Interface G01. No short. All right. Now I go to the sub interface. G01 dot. Now what VLANs do we have here? 10 and 30. 30 is upstream, so 30 is one connected to G01, and that will give me what? 30. Here we go. And that creates a sub interface encapsulation dot 30. Take note, I am not using native. There's a reason for that. I'll explain that later. What else do I need to configure? The IP address. All right, so the IP address is what? 10.10.10.1, which is /24 anyway, so .0. Okay, then I go to interface G00, no short. And for OSPF to work, I'm going to have to configure an IP address. That'll be what? 20.20.20.2. I'll give it 2.255.0. Okay, and put that there. And I go to the sub interface on G00. What sub interface should it be? Well, VLAN, right? It's VLAN 10. If you remember, we have VLAN 10 down here. Let me show you guys. This is VLAN 10, right? Let me select it. See, VLAN 10, 192.168.1.0. So that's what I'm actually going after right now. All right, so route 1, VLAN 10. I'm going to create a sub interface with 10. Oh, come on. Encapsulation dot 10. Excuse me about that. All right, so I'm going to give it an IP address, and the IP address should be 192.168.1.1/24. It's a really easy mask, so I have no problems with that. Now I'm going to configure the route, the OSPF routing protocol. OSPF. Now I'm going to just use the same. Doesn't have to be the same really. Process, as I said, is locally significant. Okay, and I'm going to put a router ID. Same idea. All right, and then I'm going to use what? The network command. Remember, I said I'm cheating. Most times in the exam, you will be asked to specify the exact mask you want, but the mask are no challenge, so I'm really not bothered about that. All right, area what? Area 0. Okay, so that should that should actually get it to work. As you can see, OSPF is loading full. It's done. So I do show IP protocol. As you can see, let me take this up a bit. The process number is 172. Router ID is 2222. Routing for networks, I cheated. What I'm pretty much saying with this command is, please advertise all my interfaces. I don't care what interface it is, just advertise them all. And look at that, it specifies that we have 2 gateways. So what it's pretty much saying is we have 2 routers in the area 0, and one of them is 111, the other one is 222. Let's see, let's do show IP OSPF neighbor to see the DR. Well, as you can see, um, the neighbor is 1.1.1, and the neighbor is the DR. It's designated router. I'm sure router 1 here is going to be the backup. No, the backup DR or BDR. And let me do that. Sure. Well, so let me do copy, run, start. All right, so I'm going to end this. Just actually going to the exec command line. That's why I use end. The reason why I'm doing this is because it's Packet Tracer. Not everything, not all the commands are available. So I'm trying to make sure that, yeah, database is available. No, actually, interface is also available, which is fine. Database, is there anything I can get here? Summary. So let's see, what summary do I have? Okay, that's it. For route, you know what? Let me just put database so it lists everything here. So I do have two. I have what is it? I have my link state type 1 and my link state type 2. There's no type 3. Now remember, type 3 is for what? Is for I think it's ABRs. It's for ABRs. Let me just double check on that. Hold on, let me just double check. I remember. Here we go. So these are the link state types. You see, link state type is sent by every router in the area. Link state type 2 is sent only by the DRs, right? Designated routers. Link state type 3 is sent by the area border routers. So I was right. Link state type 4 is sent by the area border routers that are connected to areas that are advertising. So the area border routers connected to areas that are advertising external routes, like when you have the default information originate. You know, you have a static route and you're trying to advertise static routes on another area. So you have that there. You have type 5, which are routes you get from redistribute, either from another OSPF process or other routing protocols, like static included. Then you have the not so stubby. That's type 7. When you redistribute stuff from not so stubby. So that's really what this is. Let me take this back, minimize. Let's continue with that. So that's why we have this. So I'm just making it obvious that what's going on here. Excuse me. So it tells me that the link ID is this is the DR, and the IP address of the designated router is 20.20.20.1, right? That's the link ID, and it says that the router ID of the designated router is 1111. So this is way to quickly check for information, official information there. So remember, link state type 1 advertises all the routers and usually uses their IDs, not necessarily the interface IP address. Link state type 2 actually advertises the link state advertises the interface IP address of the DR and the router ID of the DRs. All right, so let's go ahead. I think I'm done with router. Just to make sure everything's fine, let's show IP route. Usually I wouldn't need to go through all this. I'm just doing this so that you guys can follow. So show IP route. You can see the route listed here. I have, excuse me, as you can see, I have OSPF routes being advertised. I have OSPF routes being advertised. This is connected. L is local. L means the local IP address, right? or directly connected to it. All right, cool. So let's go on. I'm done with the routing. Let's go to the switch. So in this case, I'm going to switch 0. Um, I'm wondering whether I made this thing a little bit too big. All right, cool. Let's go on with that. Enable, as usual, host name. Remember, I do this just for sanity. Switch 0. Okay. All right. Now, what's important is I do know that interface F01 is connected to PC2. Interface F01. This interface here is connected to PC2 here. Right. So that's F01. And if it's connected to a PC, it should be switch port mode access and switch port access VLAN. Well, VLAN is PC1 or PC2 by my bad. PC2 is VLAN 30. Is there anything else here? No. It says VLAN does not exist, so it creates it. Take note. This switch port access VLAN actually creates the VLAN. Switch port trunk allowed doesn't create the VLAN. Expects that VLAN already created, and that's my bad. Actually, the first thing I should have done was, you know what? Let me just do it. Exit. I should have created all the VLANs for the switch. So VLAN VLAN 40 name VLAN 40. Okay, and I'm going to VLAN 30 name VLAN 30. All right, so I've named it. The name is just decorative as far as I'm concerned, or aesthetic. All right, cool. Now let's go to where's it? Interface F01 because I'm not finished with it. Interface F01. So I've configured the switch port mode access. I've configured switch port access VLAN, giving a VLAN. Now there's something important that you need to know. When you configure an interface with access or in access mode, pretty much what you're saying is this. You're telling the switch that the device connected to this port has no idea how to handle VLAN tags. Now, the VLAN tag tells it that, okay, the value of this VLAN is either 10, 20, 30, whatever you specify. Not all devices can interpret that. And if a device that cannot handle VLAN tags or frames with VLAN tags sees a frame with a VLAN tag, it's going to drop it. So what you're pretty much saying is what's connected to this port is a device that cannot handle VLANs. So recognize that frames that come into this port, that ingress this port, should be sent out with a VLAN tag on other ports. But when we are sending frames out of this port, we should remove the VLAN tags and just send the frame as is. Now, this almost replicates native. It's the same thing as when you configure. Remember when I was configuring native the routers, and I didn't use native. It was because I want my frames for VLAN 40 or VLAN 30 sent out with a VLAN header, a VLAN tag in their header. Let me just. I'm thinking that it would be useful to actually see if I can get this. All right, cool. So VLAN header. I'm gonna check images for it. Maybe we can see something that would explain everything easily. Okay. I'm not sure this is clear. All right, this is what I'm talking about. So look at this. This is a typical frame, right? This is the first one above is the frame without a VLAN tag on it. Normal frame, preamble, destination mark, source mark, ether type, that's what Ethernet or whatever type it is. The data that you're sending, that's where your IP packet, that's where your packet information is stored. And you have the CRC redundancy to check that the frame is actually okay. Um, Now with the VLAN 802.1q, oh, I was actually close. What it does is it adds this header in between the source mark and the ether type. Now, if it's a PC, the PC doesn't expect to see this, except the PC's NIC card can handle um, VLAN frames. It's not going to, it's not going to drop this and say there's something wrong here. This is not a frame I should be handling. I'm not a switch. As an example, a printer sees this, printer is dumb. Just going to drop it, So that's the problem, and that's why when you're configuring switch port mode, you have to be careful. You really need to understand why you're configuring a port as access and why you configure the other ones as trunk. So as I said, I'll say this: there are really only two major types of ports. They are either trunk or access. That's it. Now, trunk, we have three different types of trunk. We have switch port mode trunk, whereby we do not negotiate uh, to be a trunk or not. We just configure like that. It's almost like you have an Ethernet port, and you do not configure auto config. Instead, you configure speed as 100 and duplex as 4. It is not going to negotiate. It assumes that the other side has the correct configuration in it, manually configured there. So that's what switch port mode trunk does. Then switch port mode desirable. You know what? Let me just continue the configuration, and I'll keep talking about that. So switch port mode desirable actually tells you um, that actively negotiate to be a trunk. So it's dynamic, right? Dynamic desirable. Switch port mode dynamic auto means do not negotiate, but if someone or the other side negotiates to be a trunk, oblige them. That's really what it is. So let's quickly go ahead with this one. What we have here. So what do we have here? So let's go to interface F01. Just want to make sure I'm the right interface. I've configured switch port. Okay, let's just go back to switch port mode. I'm just going to do everything again because I'm not. I'm annoyed. Sorry, switch port mode access. Switch port access. VLAN 30. Now I'm going to configure security. Remember, what did it say? It said that switch port security. I'm going to enable it by just typing this, and then say switch port what? Switch port security. If you look at it, the information here specifies that I should enable port security. 1, 2. I must use the sticky map, and I must use the violation type restrict, and the maximum number of MAC addresses should be 1. So I simply do this. I go to hold on. All right, cool. So I go to violation restrict. Now take note, there are different types of violation. We have protect, restrict, shutdown. There's a great story to explain this. I actually use this to illustrate this to a friend. Now, this is one personal experience. Now, there's a particular guy in an office. He has a cubicle. He has a desktop that he works with, but sometimes he wants to download some stuff on his private computer. So he brings his laptop from home, his personal laptop, and tries to connect it to the port that is meant for the desktop. No, if he's in the office, he should be working, right? He should not be doing personal stuff, and we do not want personal stuff connected to the network. So we give him a warning. Hey, you don't do that. All right. guess what? He keeps connecting it anyway, as in he hopes that we don't see him, but he keeps connecting it. Now, because we have switch port mode, port security violation protect, what happens is we just if the frame, if the source address of the frame coming into that port is not one of the approved MAC addresses, as a source MAC address, right? It's not one of the approved MAC addresses. We just drop the frame. We don't do anything. We just drop the frame. So he will just find out that for some reason he's not getting anything. No joy. Now, if we want to actually be stricter and enforce disciplinary measures, we can use restrict. Now, restrict, what restrict does is this. Restrict is a step up on protect. So it's going to drop the frame, but it's also going to increase the violation counter. So it's going to increase the violation counter and say, hey, there's more violations over here. Why is this going on? So it's just going to increase the violation counter. And what that does is it makes things bad for, let's say it was John, because we can go back after a week and find out that he's connected a PC or he's connected a device with a different MAC address that is not approved on that same port, despite the fact that we warned him not to do it. So let's say he's done it about 7-8 times within a week. By the way, it's gonna the violation count is gonna show the date and time, right? So we would know when he did it. We can fire him and say, John, you're fired. He says why? We tell him we informed you not to connect any personal devices to the port, right? But you did. It says, where's the proof? We show him the violation count. So maybe he has 7 or 10 with a space of maybe 2 or 3 days or 4 days. We tell him, well, that's it. Then he claims that, hey, no, it wasn't done by me. It must have been someone else who came to do it. We look at the time on the violation counter and confirm that he was still swiped in the he was still swiping. He has not left the office. When he's leaving the office, he swipes out. So we're like, okay, you were in the office at this time. This violation occurred. We expect you to be at your cubicle, right? If you leave your cubicle at all, you shouldn't be off by maybe 30-40 minutes. That someone can come to your cubicle and then use the cable. Regardless, if we have a camera, which most offices have, we can actually go and look at the camera and watch for those times and see if he was at his cubicle. We may not see what he's doing, but we will see if he was at the cubicle. And if he was at the cubicle, hey, you take responsibility for it. So he gets fired. So that's what it is. Now, shutdown is a very interesting way to do it. Now, if you have a policy in the office that says if your PC is not working or stuff is not working, you have to go through your manager to, start. Most call centers are like that, to get IT to work with you. Especially when you have a major network down, not like a minor trouble, minor something thing that doesn't affect your work for the day. If it completely shuts down, that you can't do anything, you need to inform your boss. Right now, let's say you've been given that warning not to connect it. You now go ahead and John now goes ahead and connects it anyway. What shutdown does is shutdown will shut down that port and put it in error disabled state. Unless John has access to the switch to write typing commands, he cannot, or to bounce the port by saying no shot, by saying short and no shot, that port is not going to work. Even if he connects back his desktop PC, the port would not work. He would need to talk to his boss to call IT. IT would now investigate and find out that the port is in error disabled mode. We would see a violation counter there that there was an illegal frame, which means something illegal was connected to that port. He may claim, oh, nothing's there, but you know what? We've already got his boss involved. He will likely minimal. He's going to get away with a query. Max, he's going to get fired. So this really is what happens in especially places like call centers, banks, places where they are very careful about what you connect. to the network, because you can shut down the whole network just by connecting something, or introduce a foreign element like a virus or worm, you know, and compromise the security. Now, port security is really eh, bare bones. It is MAC filtering. That's all it is. It's almost like parental controls on your wireless router. Now, enough of that talk. Let's get this done. All right, so it's switch ports, port security, violation restrict. That's what specified. Now, we also said the maximum number is what? One. By default is one anyway. All right, cool. And it also says that the MAC address should be lent MAC should be lent by sticky. So we have two choices here. We can either manually type in the MAC address or put in the sticky command for it. So I'm going to put in the sticky here. Sticky just says whatever MAC address you see there, just go with the flow, accept it. All right. So is there anything else? Yeah, just sticky. So I'm going to compute that, and I'm done with that port. Do copy, run, start. All right, cool. Next, I'm gonna go for interface F02. I believe F02 is connected to PC3. Let me just make sure. Yeah, it's connected to PC3. All right. Okay, so I'm gonna go to interface F02. There's also switch port mode access. Remember, it's a PC, so it's dumb. It can't. Well, it's not dumb. It just can't handle VLAN tags. So switch port access, VLAN. What VLAN is on this one? 40, I believe. Yes, 40. Just wanted to make sure. All right, switch port access VLAN 40. Now, because I've configured VLAN 40, I didn't get that error of creating VLAN or that information of creating the VLAN. So I'm fine. Next, what do I do? I need to configure the violation, right? So that's switch port security. You know what? I want to enable port security here. I'll just type the what's it? Maximum. Maximum by default is one, really. Maximum one. Now I'm going to do a trick here. I do not know what the MAC address of the PC is, so I'm going to go to IP configuration. I'm going to make this DHCP, so it's going to send stuff. Now, what happens? Do you remember what happens when you do DHCP and DHCP fails, and the PC doesn't get an IP address? It uses this 169.254. This is a special IP address. It's just like a link local. It's a link local version of IPv4. You know what we have in IPv6 as a link local? We have the same in IPv4, just so that PCs can easily connect, despite the fact they do not have DHCP running. Now, because I've done this, what it means is that I can actually now run this command, ipconfig all, ipconfig, and I should be able to get a MAC address. Ooh, tough. All right, I still can get a MAC address. This is a link local address. Now, from this link local address, I can still guess that. Let's see. Link local address. MAC addresses are tree, right? So what link local address does is this. It gives you the FE80. It puts something in front. Then the last two here, 06 is one of the MAC addresses. We have 2A is one of the MAC addresses. This is placed in between your MAC address. Next MAC address, next part of MAC address is actually 93 and 16E7. So that should be the MAC address. But you know what? I'm going to do this ipconfig all, and hopefully I should be able to see and I'm right. Look at that. So the physical interface on what? IPv6 is 00006 2A9316E7. If we look at the link local on IPv6, what do we have? We have FE80, we have something 206. You can see here is this 0006. We have 2A. Like I said, this FF and FE is placed in the middle. That's about it. And then we have the 93, right? You can see 93 here. So we have 2A, FFFE is placed in there just to separate the MAC addresses, MAC address into two, and adopt the MAC address into IPv6 address, IP address. I got my MAC address that I need, and this is the MAC address I need. I'm going to copy this. I'm going to go back here to the switch, and I'm going to say switch port MAC address. I'm going to type in the paste the MAC address manually. Well, first of all, let me show you how it should be. You see, it should be in 3 installments. First hex. Is it hexet? First hex, second hex, third hex. All right, so which is the same format I placed it here, and I'm going to enter, and that should do it. Now, take note, I did not enable switch port security because if I do, some defaults kick in. I need to configure everything first before I enable port security, so that I do not get a problem. I do not get errors. Now that I've done this, let me just double check on it. Do show port security, right? A port security shows that I have 2 interfaces running port security, FA01, FA02. We have the max secure address is 1. Same here. The current address is 0 on FA0, but is 1 on FA02. Take a few seconds and think, why do we have this current address count here as 0 here and 1 here? If you just remember what I did in the video prior, just 3 seconds. I can't wait for 3 seconds. I gotta tell you. All right. Pretty much what this means is this: it's saying that what MAC address did I see, right? And the MAC address you see, it saw there. It saw a DHCP. Remember the PCT? It's actually still configured as DHCP. So it did see a frame, a DHCP frame being sent, and that's how he learns it. If I'm going to put it back to static, which I'll have to anyway, that's why it shows up as count 1. The PC over there, PC2, is still on static, so there was no frame sent. Right, no frame has been sent, which is why it only saw a frame on FA02. All right, now violation count is what? 0. Security action restrict. Ooh, I forgot this. The information says it should be shut. It shouldn't be shut down. Note shutdown is default. It's a good thing I actually configure it that way so that you actually can see what I'm talking about. Shutdown is the default mode for default violation for port security. I always thought this was sanity's sake, just to make sure I'm in the right interface. Okay. So I'm gonna have to do switch port. I'm gonna change it to switch port security violation. I actually thought I configured it. Violation restrict. All right, and now I can do that to show port security. See, they're both restrict. Now, if I want to get more details, do copy, run start. I do hope this is still meaningful to you guys. I'm gonna edit this, but let's show more details in regards to port security. Guys, do show port security interface F01. All right, so we got some information here. We have port security is enabled, port status is secure up, violation is restrict, Aging time is 0. Absolute aging time, aging type is absolute. Um, so it doesn't age. Secure static addresses, aging disabled. Maximum MAC addresses is 1. Remember, we configured that. Last source address is 0000. Remember, we have sticky configured, but we've not sent anything yet. So that's why it says I haven't learned anything from sticky. And the last source IP address, source MAC address that we saw is we've not seen anything. The PC has not sent us a single frame. Violation count, not there. So we can't get much information from packet tracer. It's unfortunate. For security, right? So interface F um, F02. All right, let me put address. So the address should say show secure address of the interface. But it shows me absolutely not. All right, cool. Let me just do this too. All right, cool. So this is for 2. Is enabled. Port security is enabled. The type violation type or violation mode is restrict. We do have the 1 maximum address, MAC address. The total address is 1. The configured address is 1. This configured address tells me that it's manual. Take note, sticky address is what? Absolutely 0. All right, and the last source address is this. Do you guys realize that you see that it says what? Take note, this is something we should actually not forget. You see that colon here? The colon here is telling you the VLAN. So it says the MAC address of the PC, if you remember this MAC address, and it's seen on what? VLAN what? 40. So that's what it means. So violation count, has there been any violations? Absolutely no violations so far, 0. All right, now it's packet tracer, we can get much more information than that. I'm done with those access mode ports. Now I want to configure my trunk link to the router. Okay, let's quickly do this. I'm almost guessing it's F03, but I can't be sure. Let me just make sure. Oh crap. Okay, I think it's F03. Yeah, it's 3. Yeah. The guy didn't do any favors by putting all those stuff so close together. So F03. All right, interface F03. Remember, it's a trunk port, but I want to use dynamic desirable. So I'm going to go with switch port mode, dynamic desirable. Remember, I want desirable. Uh, desirable. I want it to be desirable so that it actively negotiates. All right, dynamic desirable. Next, what do I want to do? I want to switch port. I want the switch port trunk. I want allow VLANs to be 1 and 40. Now, Packet Tracer has a problem. Allowed VLANs actually. One Packet Tracer has a problem. I don't know why. It doesn't take this. Once you type in this command, right? I'm on interface F03, right? It should take it and it should show up in show run. Another thing is when you do show, was it show interface trunk, I think. It should show a trunk port, but we're not seeing any. Another thing is if I do a show VLAN, my my port 3 should not be listed. Port 3 should not be listed. So this is the problem. This is a problem with Packet Tracer. So guys, if you have this run through this problem, this is what is going on. For some reason, Packet Tracer does not work well. That's Packet Tracer 6 point, I think, 1. Is it 6.1 or 6.2? But it does not work well with dynamic desirable. What you have to do to get this to work is actually configure it as a trunk port first, and that's what I'm going to do for switch port. I noticed that, and it's very annoying. You don't really need to go through all this in GNS3. It works in GNS3. All right, so switch port mode, trunk is what you need to now do to bounce it. And remember, I think it's because we do not have anything like switch port mode, dynamic desirable. So there's a breaking code somewhere. You actually have to use switch port mode trunk, then go back. Let me do show VLANs. This is really sad, but yeah, you see the F003 is gone. I start with F04. Now I actually have to go back. Now I can actually leave it this way, but I'm trying to use the dynamic so that it would negotiate. So let's do this. Switch port in switch port mode, dynamic, desirable, and it still stays. It still shows. The trunk still now works. So it's unfortunate, but that's the way it is. Show VLAN. I'm having a small headache. Yeah, so you can see the FA03 is still not there anymore. And let's do interface trunk. Now we have trunk information. You see mode desirable. So the command works, but you need to, for Packet Tracer, you need to turn it as trunk first to let Packet Tracer work as a trunk. It's only local to Packet Tracer 6.2, I think. So just be aware of that. All right, so I'm going to do the same thing for my interface F04, which I think is what this is. Yeah, it's F04 connected to the other router. I'm going to also make it a trunk. So I'm going to start off with switch port mode, trunk. Remember, the reason why I said I'm doing this is because it would not add it anyway. So then switch port, trunk, allowed VLANs. One. Did I even get the right one? The first one right? 1 and 40, 1 and 30. All right, cool. So 4 is 30. 1 and 30. Now I'm going to go back to switch port mode and make it dynamic, desirable. Oh, come on. Dynamic, desirable. I don't know what's wrong with Packet Tracer really. Right, so just to confirm that my interface trunk. Yep. So I have F03 and F04. Both are trunk ports. As you can see, they are both in desirable mode. They both have a native VLAN of 1. So all frames sent on VLAN 1 are going to be sent untagged. That's what it means. Remember the access ports, the switch port mode access explanation I made? All right, cool. Now, next is the ports. VLAN ports allow. I am allowing on FA03. I'm allowing VLAN 1 and 40. Now, F03 is connected to PC2. PC2 uses VLAN. Oh, no. Oh, okay. My bad. F03 is connected to router 0. You see, I get this thing mixed up. I saw this F03 and I thought it was connected to PC2. It's actually router 0. All right, so it's connected to router 0. And the VLANs here are 20 and 40. So I'm using 1 and 40 because 40 is for upstream. And F04 is connected to router 1. That's 1 and 30. See this over here? All right, cool. So that's basically what I did. I configured this. I configured it as trunk ports. All right, cool. And I'm